The following video has been produced thanks to a collaboration between the Middle School Casteller in Postioma, the Geologists Association of the Veneto region, the National Fire Department in Treviso, and the Civil Protection Department of the Veneto region. They are working together on an experimental project dealing with the dissemination of the knowledge concerning the fragility of the area. The main aim of this effective collaboration is to let students become future European citizens who are actively involved in the sustainable management of the geological risks in their country, which means being able to live together with the forces of nature.
The internal structure of our planet is composed of a series of concentric circles. They give birth to a series of layers, which wrap the Earth as if it were an onion. The outermost circle is called Earth's crust, which is like a very thin film compared to all the others. The Earth's crust is thicker under the continents, and it is thinner under the oceans. Under the Earth's crust there is the mantle. Its upper rigid part is called lithospheric mantle. The lithospheric mantle and the Earth's crust make the lithosphere. Under the lithospheric mantle there is the asthenospheric mantle, which has a fluid plastic movement. If in the asthenospheric mantle there are points with different temperature, they can cause a movement of magma called convective motion. Due to friction, the magma moving in the asthenosphere drags the upper lithosphere, breaking it into plaques moving like rafts, and generate what Alfred Wegener called the continental drift.
In this slide, we have highlighted the areas where the new oceanic crust takes place, and the areas where the continents collide and the crust is swallowed under other crust. Almost all earthquakes take place along the ridges and the subduction zones. In 2011, there were nearly 10,000 earthquakes, which have overcome magnitude 4.5. The earthquakes, which origin along the subduction zones, can cause catastrophic effects. A lot of people live in those places in Japan. In this slide, we can see the effects of the tectonics of the crustal plates has caused in the latest 400 million years, since we can find out in detail the movements of the various continents. The continents were all a single continent, called Pangaea. Within this supercontinent there was a gulf called Tethide, and it was surrounded by ocean called Pantalassa. Years passing by, Pangaea divided itself into two parts, Gondwana to the south and Eurasia to the north. Antarctica, Africa, Southern America, India, Madagascar and Australia generated from Gondwana. Northern America, Europe and Asia generated from Eurasia. In the future, we can foresee the closing of the Mediterranean Sea, and this will give a rise to a single enormous mountain range. It will incorporate the mountains of North Africa, as well as the Pyrenees, the Alps, the Apennines, till the Himalaya mountains. There will be a very long mountain ridge joining Africa to China. In a 200 million time, this movement will go on till a new Pangaea.
These movements, which break and make the continents collide, give rise to the faults, which can be considered as the true factories of earthquake. Earthquake take origin along the scroll surface of the fault. This video will show us the earthquake in 2011 all over the world. They overcame magnitude 4.5. The dimension of the range and intensity of the sound are proportional to the intensity of the earthquake. As regards Italy and Adriatic play, we can say that southern Italy moves towards northeast for 5 mm a year. The oriental part of the Po Valley moves to 2.5 mm a year. This fact causes a rotation of Italy counterclockwise. The fulcrum axis of rotation is located in the west part of the Piemonte region at the edge of the Alps. This rotation pushes the Apennine to clash against the Dinarides and closes progressively the Po Valley. These movements will generate huge earthquakes and they will cause an uplift of the Po Valley. Nowadays, it is still not possible to predict when an earthquake will take place, but we can definitely say in the future there will be a lot of intense ones.
As for Italy, if we take a look at the distribution of earthquakes in the last 1000 years, we can see that they are mainly concentrated in central South Italy and in the northeast of it. The strongest one in central South Italy take place every 300-400 years, while in northern Italy they happen every 500 years. We can remember the fact that in the city of L'Aquila there was a terrible earthquake in 1700 and one in another famous town, Ferrara, at the end of the 16th century. The main problem lies in the fact that we have forgotten that Italy has a high seismic risk. In Japan, both public buildings and private ones are built according to anti-seismic criteria. It is curious to see that new buildings and very old ones are built according to the same criteria. If you have a walk along the streets in Treviso, you can see that many old houses have iron plates on the external walls. These plates are held fast by a bolt. In these houses, sometimes we can see some iron bars on the ceiling. These bars cross the rooms. In other countries, France, Germany and Turkey, we can find wooden joists diagonally laid on the walls. During the last catastrophic earthquake in Ankara, we saw recently built concrete building collapse. On the contrary, in the ancient, abandoned, run-down Ottoman district, the houses were not damaged. They survived the quake. The building technique was that of putting wooden joists diagonally laid within the walls. In other words, if we build consciously, the damages can be nearly totally avoided. In order to be consciously, we have to know the territory we are going to build on. The knowledge of the territory is not so widely spread among the Italian population, and sometimes Italian people have turned out to be too optimistic about the Italian geological situation. If we observe the geological map the Veneto region made and published in the 90s, we can see that all the faults which gave rise to the earthquake in the Emilia-Romagna region had been well highlighted. If we have a look at our region Veneto, we see that the map highlights many active faults. Among these, we can remember the fault in Montebelluna, the fault in Ervesa, the fault of Val Malor in the Montello Hills. We can see then two other very important faults which show how the area of the Montello overlapped the plain area. These faults, which are technically called overthrust, are the Aviano line, which passes below the Montello, and the Sacile line, which passes below Postioma, where our school is located.
The liquefaction of sands represents one of the most impressive events during earthquakes. This phenomenon causes the coming out of sands out of the cracks in the ground. This sand behaves as if it were liquid substance. This picture shows you how some streets were completely wet and covered by mud, as if it had just stopped raining. On the contrary, that mud came from the subsoil, and that was just the sand in its liquid state. This other picture shows you the main path in a graveyard totally covered by grey sand. Thanks to these aerial images, we can see some grey lines crossing the fields. These pictures show the cracks which caused the dislocation of the opposite borders in the ground. When they get to the buildings, these dislocations cause the breaking of the masonry structures. But where does this sand come from?
This sand is placed in the deepest layer of the ground, and it is soaked with groundwater. The earthquake has caused a series of vibration and compression. These vibration and compression have made the sand a liquid. It has been pushed out of the ground the same way we squeeze a tube of toothpaste. The video shows us how, in normal condition, the thick sand, soaked with water, has a great bearing capacity. If we let this sand undergo a shaking movement, see what happens during an earthquake, we can notice that it totally loses its bearing capacity and works as a liquid substance. From this image, we can understand what the liquefaction of sand can cause. These buildings have lain down on one side due to the subsidence of the foundation of the house. It was caused by the liquefaction of sand, which made the ground lose its bearing capacity. This event happened in Turkey on 17 August 1999. A big part of Turkey was shocked and destroyed by a 7.2 magnitude earthquake.
To sum up, we can say that Italy is a highly seismic risk country. Although Italy doesn't have such a high frequency recurrence of earthquakes like Japan, our country has had quite a lot of earthquakes which have destroyed whole towns. We must not consider the Po Valley a low seismic risk place. We must take into account its varied geological structures. Actually, we cannot foresee the exact day, month when an earthquake will surely take place, but at least we can foresee the probable period of time during which that event may happen. It has been shown that catastrophic earthquakes in L'Aquila take place at every 300-400 years. The earthquakes in the Po Valley seem to happen in wider intervals of time. Ferrara was totally destroyed in 1570. In our region and in the town we live in, we had strong earthquakes in 1100 and at the end of the 17th century. We can foresee that in the future we will probably have 6.5 magnitude earthquakes or even stronger ones.